Yes, what is system? When you think of systems, more than one, right? Okay, but what type of equations are we dealing with here? What type of equations are we dealing with? What kind of figure do you get when you graph these equations? A line. These are linear equations. A line, right? Linear equations. Because they're in the form of y equals mx plus b, which is slope-intercept form, right? Everybody remember from algebra 1? Okay, if I have two lines, what are going to be my solutions or outcomes? I'm going to have three of them. Quiet down, guys. If I draw two lines on a graph, what kind of solutions or outcomes do I have? They intersect, right? Okay, so the first one, they're going to intersect. Intersection. So when they intersect, what's going to be my answer? Two lines intersect on a graph. I'll do a very crude graph here. Okay. Here's my graph. It's my y-axis. Here's my x-axis. Okay. I have two lines. Oh, I don't know. One here and one here. Okay. I get exactly 1 point, correct? Okay. So your solution's going to be exactly 1 point, and you're going to have an ordered pair as your solution. Okay. So that's the first one. Lines can intersect. And I get exactly one solution. And that solution is going to be a point. And it has to be in the form of x comma y, an ordered pair. Okay. What's the second? Huh? Parallel lines. Wonderful. If I have parallel lines, what's going to be my solution? What point is going to work in both lines at the same time? What point is going to work? This one, I know that this point works in both of these lines as a solution. What about these two? What point is going to work? Huh? 0. There is no solution for parallel lines. When you get parallel lines, there's no solution. When you get parallel lines, you must state no solution. When you're doing it algebraically, what kind of answer do you get? When you're doing it algebraically, not a graph, you're going to be doing it algebraically, what kind of solution are you going to get? You're going to get an untrue statement. For example, you're going to get 6 equals 0 or negative 4 equals 3. You're going to get an untrue statement. So there's two of them. What about the third one? Okay, I've got intersecting ones. Gives me a point, exactly one solution. I have parallel lines that doesn't have any solution at all. how else can I draw another line that's different from these two conditions? Anybody? Hey, Butthead, you know the answer? If I draw another line right on top of this, I draw another line right on top of this. Okay? How many points do I get that are in common? All of them. Wonderful. So the third one is the same line. And I get all the points in common. So how am I going to state that? How many solutions? All of them. How can I state that mathematically? Infinitely many solutions, right? Thank you. Now you can abbreviate this to INF, many solutions. Okay. Now, what's that going to look like algebraically, Noah? What's that going to look like algebraically? I'm going to get something equals something, right? Algebraically. You guys remember? You're going to get the same number equals the same number. 0 equals 0. 2 equals 2. When you get that, you know you have infinitely many solutions. 3 conditions with systems of equations. By the way, systems of equations, if you guys, any of you want to engineering or higher mathematics, systems can involve hundreds, thousands of variables, unknown variables. When you get into computers, engineering using determinants a lot, it could go forever. So you will be dealing with systems a lot. So if you're thinking about going in, especially like the engineering field, you need to know all this stuff. All right, so number one, and we have 3 different methods, a lot of different methods. We're going to I'm going to teach you, or you should know, the 3 different methods in Algebra 1. Okay, the first method is graphing, solving systems by graphing. And you do that by graphing each line. Now, these are in slope-intercept form. If they're not in slope-intercept form, you need to put them in slope-intercept form. Hence, the reason why I had you guys isolate variables for 3 days. Because you're going to have to do that with some of these equations. See how things work together? Scaffolding, right? All right. What is my y-intercept here in the first equation? What's my b? Y equals mx plus b. What's my b? -1. What do I mean by y-intercept? Where it crosses the y-axis. Wonderful. Boy, you were listening to me in Algebra 1. Wonderful. All right, what's my slope? 2/3. Remember, it's rise over run, so it's y, the change of y over change of x. Okay, you're going to go up or down first, and left or right. So I start at -1. That's where it crosses the y-axis. Here, these are both positive, so I'm going to go up 2 to the right 3. Or I could put a negative sign in both of those because that's the same fraction. I can go down 2 and to the left 3. Now, you should be drawing lines. Technically, you can get away without drawing a line, but since I'm a perfect mathematician, I had to draw a line. So there's my first equation. What about my second one? Start at 3, and my slope is going to be wonderful. Start at 3, up 2 over 1. I could also go down 2 and to the left 1. And I could do that until I cross this line. And I get my solution there, right? What is it? Well, look at your own paper because you're writing this down. So what's my solution? Point, -3, -3. Now, you could always check these. What about number 2? Graphic. Good. The b is -1. That's the top one. And my slope is -1 over 1, or 1 over -1. So here's -1 crossing the y-axis. And I'm going to go down 1 to the right 1, down 1 to the right 1, or I can go up 1 to the left 1, up 1 to the left 1, and so forth. If you don't feel like drawing the lines, okay, b, -4, slope 2 over 1, start at -4, up 2 over 1. There's my point of intersection. My answer is C, 1, -2. You must put the ordered pair on exactly one solution. If you don't, it might take a half point off. So that's graphing method. Solving equations by graphing. The second method I don't know how anybody can take 40 minutes to make up. Wow. Wow. That hurts. That hurts. Wow. Man, that hurts. Second method, substitution. Okay, substitution. The first thing you got to do is isolate a variable. Hey, we know how to do that now. Once you isolated a variable, you take what that value is and substitute it into the other equation. They're kind of nice here, where they've got y already solved for. Y equals -2x plus 2. So I'm just going to substitute it in the other equation where the y is. Now, I've seen all kinds of mistakes happen to this. I would, if I were you, I would write down the equation the way it is, negative 3x minus 8, and where the y is supposed to be substituted into, put parentheses there. That's my y equals 10. And then all I'm going to do is substitute what my y is. Negative 2x plus 2. That way I don't make mistakes, especially when you have to distribute. Okay, so I have negative 3x. I have to distribute minus 8 times minus 2x to positive 16x. Negative 8 times positive 2 is negative 16 equals 10. Now I just solve for x. Negative 3x, positive 16x, 13x. Glad they gave us enough room here. I'm going to add 16 to both sides. So 13x equals 26. So what does x equal? That's right, 2. Okay, divide both sides by the coefficient 13. Now, am I done? No, because I only found one of the coordinates in my ordered pair. I've only found the x value to be 2. I got to go back and find y. Pick one of the original equations. It doesn't matter which one. Sometimes one's easier than the other, but it doesn't matter. You'll get the same answer. Let's pick the bottom one. Y equals negative 2. I'm going to put my x in here, plus 2. My x is 2. So y equals negative 2 times 2 is negative 4 plus 2. So my y equals negative 2. You have to put it in ordered pair again. And then the last method, solve by elimination. Solve by elimination. The way that this one works, remember, is you're going to add the two equations together. You're going to add the two equations together, and you're going to eliminate one of the variables when you add them. This particular example, you're not going to be able to eliminate when you add these together. So you're going to have to multiply one of the equations or both of the equations by a number so that when you add them, you eliminate one of the variables. Now, let's look at number 6. There isn't a common factor to, that 9, 3, 5, and 8 go into it, and if there is, it's going to be really big. I want to eliminate one of the variables. This is kind of a messy one. It's actually kind of difficult. I'm going to have to multiply both equations with something. Now, if I want to get rid of the y's, I would multiply the other equation by the coefficient. In other words, I would multiply the top by 8, multiply the bottom by 3. They have different signs, so I don't have to worry about the signs. If I want to get rid of the x's, I would multiply, I don't have to worry about the signs because they're opposite already. I would have to multiply the bottom equation by the 9 and the top one by the 5. So which one do you want to get rid of? X's or y's? Y's. Okay. So I'm going to multiply. We're getting rid of the y's. So I'm going to multiply the top one by the 8. And I'm going to multiply the bottom one by the 3. And again, I want to stress here, I'm not going to worry about the signs because I have opposite signs already. If I didn't have opposite signs, I would have to multiply by 8 negative 3 or something. Negative 8. Okay. Once I do that, 8 times 9x is 72x. 8 times minus 3y is minus 24y. Don't forget the negative 18. That'd be 4, 6, 144. Don't forget the negative. Okay, then distribute the 3. 3 times negative 5x, negative 15x. 3 times 8y. It better be the opposite of this one because we're trying to eliminate the y's. And then 3 times 10, 30. Then you're going to add these two equations together. When you add them, one of the variables has to eliminate. It has to add up to 0. If it doesn't, you did something wrong. Stop. Start over again. Okay, 72x plus a negative 15x, so I'm subtracting here. See, 7, 1 from 6 is 5. Again, negative and a positive, so I'm subtracting. So I get 4, negative 11. Divide both sides by 57. These cancel 1. 1 times x is just x. Negative 114 divided by 7, negative 2. I just used 3 instead of negative 3 because in my original equation, they're already opposite signs. Okay? If they're the same sign, I'm going to have to multiply by one of these equations by either, a negative. Okay? Now I've got my x. I got to go back and get my y. Does it matter which one? No. This time I would probably choose the bottom one. Just what I would do. My x is negative 2. 8 times y. And I have positive 10. Negative 5 times negative 2, positive 10, plus 8y equals 10. I'm going to subtract 10 from each side. I get 8y equals 0. Don't stop there. Okay, most students will say, oh, it doesn't work. I got a 0. I got to skip it. Don't do that. 0, you can divide a number into. It's the other way around. A number divided by 0 is 5. But I can divide a number 0 by a number. 0 divided by 8 is 0. Okay? So my solution here is my x is negative 2, and then my y is 0. Don't worry about the word problems. For now, we'll go back and do them. Those are our 3 methods. You should have enough ammo now to do the practice. Okay, there's only 6 problems. You should have time after the review. So if you don't get to it tonight, you can do